Testing. Okay. Pause share. All right, it's a Coffee Compiler Club. We've been talking about home buying rules and escrow monies and inspections and lethality of 60 hertz versus 50 versus 220 or whatever. Not a whole lot of compilers yet. Anyhow, this is pre-recorded, and hopefully we'll all be on YouTube within a couple hours, and maybe we'll talk about compilers.
Yeah, we should have just kept talking about houses and electricity without any comment at all, and
just cut in on the video and keep on going and be like, wait.
The great thing is, because we're software engineers, we're experts in everything. If you guys need any advice on COVID or attacking another country, let me know, because over the past couple of weeks, I've become an expert.
Excellent. Jeez.
No, if you need to see my expertise, just check out my Twitter, because I put my brilliance there every day.
Okay.
You are bold, sir.
I swear, everything Henry Kissinger ever learned, he got from my Twitter feed.
Fun. Okay, there is a survey from the Twitter. We can start with this.
Okay, let's do this thing. Yeah, I went and asked the world, like, what the hell do with polymorphic types?
Yeah.
And I got a bunch of responses, and one very awkward one from Brian Getz, who said C++ is good enough then, it's good enough now. And polling 250 people is not a really good poll. And I'm like, obviously, what the hell? We're all self-selected anyhow. Fine. I got way more responses than I thought I would.
I will say 250 people following Cliff Click is probably better than a randomly selected 250.
There are a lot more people following me than 250. That's kind of nice. But 250 responses, I thought that was good.
Do you have a link?
Almost 10%.
Yeah, I think it's the survey expired, but we can vote here in the doc with the plus and minus. With the...
But don't double vote if you've already voted. Let's let it roll.
Okay.
Is there a link somewhere
to the survey? It's my Twitter feed. How do I?
Sure.
Find me on Twitter. You can see their survey results, but just put them in the doc.
Mm-hmm.
Cut and paste. And the survey closed after standard one day. I just wouldn't run it forever. Yeah. So out of this came like half the world wants angles because Java and C++, and some significant fraction of the world said spaces look better. And I got a reasonably good response that I liked. And everyone else said squares and rounds with various amounts of hate involved. I was leaning for squares until I got shown what hell happens to you if you get complicated types. So people take the read. I aligned very carefully all the different variations. And then there's the spaces read better for more complicated types too. And the type that's given there is actually a reasonably sane one. It's like you're doing TypeScript, is JavaScript types. And you have an asynchronous function, and it's going to return a result, which is the wrapper that says I can either have an answer or I got an error. If you got an error, it's an E, which is probably a string. If you got a result, it happens to be a version, whatever thing. Okay, fine. You went to a database. The database disconnected, so you didn't get an answer back, got an error, or the database connected and gave you some version answer. So that's that's the kind of types that you can imagine writing for real. And I have to say, when I pile on the angle brackets, it starts to get pretty ugly. So I'm inclined to say the parens, and the parens are just really for proper grouping. So they're not sort of part of the required syntax. They are how you group the types.
Parens?
The paren diversion. They're not part of the type per se, except that the type's ambiguous without the parens. So if you look at my spaces version of my fun equals map kv key : k.
We can share a screen.
Oh yeah, let me share the screen. That's a good answer. People go back.
So in your mind, map here is a function from a type to a type?
Map is oh yeah. I mean, for performance reasons, you want map, you're hoping it's a hash table and it does something quick and does a lookup, whatever. But as a
No, I don't mean the actual map from key to value types. Map itself is a thing that takes two types and returns a new type, which is map from A to B. A and B are parameters to the function map.
you can you could curry map. Is that what
I
you're
think in this case, map is referring to the data structure, not the function map.
Yeah, there's a lowercase.
Is that what you're asking, Aaron? Because
No.
in most languages,
So
that
you're
are
trying to make a new
functionally oriented,
type.
The word map is the function.
You're trying to make a new type that is parameterized by two types.
Yes.
So essentially you have the generic map, which is a function, which takes the two types that it is parameterized over and gives you back the data structure of the two types.
There are people who voted for that version or thought about it that way, and I do not think about it that way. But there are definitely, in one of my Twitter feed argument discussions here, there was actually somebody saying exactly this thing. Let me see if I can go find it.
That's one of those things that I always found to be just slightly too clever, because the same people also then often use the type name as the constructor as well. And then it's like, okay, am I constructing or am I parameterizing?
Right. Yes. So for me, I'm considering the capitalized map a type that has two other types as part of its type description, if you will. And so they're given a name, KV, and then you can use them elsewhere in the function description, but they're all types. It's not a function, it's not a higher level function that takes type arguments and returns a type result, not in my head. But there, like I said, there are people on the Twitter feed who said that, and I was like, oh, that's kind of weird. See, Matt's basically saying something like that. He's not, but he's saying it's just like a function call. So you in the chat. So it's round parens so that you can consider it a function call. That's what I would call the rounds version. And I didn't like that as much because I felt like it did make it look like a function call. And I don't want it to be thought of as a function. I'm with Cameron. It's too.
I would say it is a function call. That's the most natural way to think about it. I mean, forget about C++. Suppose C++ never happened and you were just inventing the syntax for generics. If you were just following the existing mathematical formulas or type theory in system F, you would note that type application is just an application, just like a function application is. Instead of the little lambda, you have the big lambda in system F. But formally, it's the same thing.
Matt, you're very loud,
Oh,
and I don't know why. It's okay. I just fought with Simon. He was very quiet, and we were trying to get our volumes level.
Well, on average, then it's perfect.
Okay, that's better.
So parameterizing a type, you can do as a function call, but is it the function call with no name other than the type itself? Right. So you only get one implicit function on a type. Do you want that to be the parameterization of the type or something else, or do you want to leave it open because it's confusing no matter what you associate with it?
Yeah.
I mean, again, we're talking flavors of implicitness, right?
Yeah.
So implicitness is both awesome and horrible, depending on what you're used to.
I generally always ask when this question comes up, is the language dependently typed? So is there a difference between, is there a difference between a value and a type? And if the answer, no, there isn't any, then I say, then the round parents of the parentheses are okay, otherwise squares. It's like, it's not even.
Okay, I definitely am not doing dependent types. I hear you.
Yeah. So yeah, and that's like if there's distinction between a type and a term or value or something, then use different ones, and I use squares. I don't.
Yeah, if any arbitrary function can't return a type, it is tempting to avoid the rounds because it implies this is just a function like any other function.
Yeah, it's not the case that you're returning, that I'm letting you return types. Now, I might have reflective abilities where you take a specific step to convert from some form to a type and from a type back to some other form, some concrete form, but I don't know. Like the standard Java reflection is I take a string, I do class for name, I get a type back. There's some kind of a thing step that you went from left to right on, and there's a right to left version floating around. And I'm like, I want that to be explicit. So dependent types in my head would be exactly not the explicit. There would be types and values are interleaved, and I'm not too much.
I'm not sure whether I argued against the angle brackets in this group already, but my usual argument is that if it's hard to pass for compiler, there's a large likelihood that it's also hard to pass for a reader. And if you compare the languages over the last 5 decades or something, all of them had issues because they used the angle brackets both for generic types and as binary comparison operators.
Yeah, but so they show up in operators all the time.
Sorry?
Yes. For me, the angle brackets immediately pop my head into, here's a conditional expression. Oh, no, it's a type.
Yeah. And if you look at the languages, I think C++ had the issue for decades that you had to add a space between 2 closing angle brackets, because otherwise the closing template type thing was interpreted as a right shift or something.
Yeah,
and,
right.
In C# you have the issue that they hit the left angle bracket somewhere in the code in expression context, and they just decide, well, we keep parsing the whole thing and have like a few things like a semicolon or a parent or something else.
But Matt, that's a different comment.
That's basically like until we basically parse it and don't decide for an unlimited amount of tokens and hope that somewhere in the token stream there is a token that tells us whether this is a comparison or a generic
or a generic type of some kind. Yeah.
In the end, the angle brackets are just they aren't worth it. I understand why C++ made it the decision back in the time, but at this point it's just technical debt and legacy craft.
But there's something implicit going on here in the definition of a map, as I highlighted here.
You put an apostrophe, and you are so set in your head there. I mean, you're so habit formed. You didn't drop the apostrophe. So edit the line.
Should I continue?
I'm sorry. I'm laughing at the chat. We're going back and forth here between the chat and the.
No problem.
Go for it, good TR.
If you parameterize the function here and here, and not in the Scala lay, like here and key and value here, how can you tell if you parameterize more than one type, if you will, here, how can you tell that this type is the same as this type, or the name should
So for the language that I'm trying to design, on the left-hand side, I'm assigning as a variable. Variables don't have to have a type. So my fun is just a normal everyday variable, happens to be
when you say variables don't have to have a type, what you mean is the programmer does not have to specify a type.
Right, and the type will be inferred. Okay, now in the middle of the map expression there, I'm going to claim that capital K has a scope that is limited by the parameter list of the function. And I'm totally happy to claim that I don't know what the hell I'm talking about, and that actually doesn't work in practice. But I would claim that K has scope at least as big as the parameter list on the function call, but maybe throughout the body of the function, but not outside of it. So I'm going to claim, sorry, a bunch of people just piling in here. I'm going to claim that that I'm going to scope those type variables, and they only will appear inside of type expressions as well. So K becomes a type variable that's inside a future type expression after it's first introduced by the map.
Because here is not the type definition of a map, here is the type application of the map where you parameterize it. So here, this is a function which is parameterized the map. Okay.
My fun is a normal variable being assigned an anonymous function. It is not a function definition. It is a normal variable being assigned an anonymous function. Okay, now I have an anonymous function. The anonymous function is the thing that you got from map through to the end. It has an argument list, an arrow, and an expression body. Okay, in the argument list, I have a first type map who has dependent types or subtypes or however you want to do it, type arguments. Those type arguments want to have a scope they're associated with that is exceeding the type expression. Like I could claim that K is only alive in this part because that is the single parse of a type expression. But that removes the point of having K around at all because, you know. Okay, so then I'm going to uplift K to be inside any type expression that's inside the curly braces.
So it's bound by the scope. Okay.
It's bound by the scope, but the namespace is limited to types. That was my current theory on how I was going to type that, scope that.
So if you add more things like map and key in there, like some unrelated things, you have to make sure that you don't reuse the same. Yeah,
you have to pick new names, or the expressed intent is that it's all the same type, and I'll do a classic Hindley Milner and bind them all up together.
All right.
And then I use a unspecified type.
Yeah.
If I make a type K, but I don't tell you what type K is.
Well, that's what you did.
But I use it for two different parameters. So I say this is a function that takes A, which is a K, and B, which is a K. It will say these two things, I don't know what type they are, but I know they are the same type.
So here I said, I've highlighted map in the document. Where did it come from? So if I have no, this is a reasonable question now. If I have a prior type definition for map, I'm going to use it. But if I've never seen map before in my life, do I want to claim that you've got a new anonymous variable that no one has ever seen before and ends at the end of this scope, such that the map that's in the first squares is different from the map that's in the rounds because it's a new anonymous variable that ends at the end of the scope? Or do I say, having used map once in squares or angles, it's the same map and the same map and the same map all throughout this whole column of maps. And now if you later define
I would say
a map,
that scope ended. If it's not defined in the wider scope, then
where does the map? Yeah, what's the scope? So dependent types here, I'm going to claim that's pretty easy. I can go to the scope of map, and then I can go one up from that, so that you can reuse the dependent type in another type over here. So K of there is the same as the K inside of the map brackets. Okay. But if if I've defined map beforehand, so if I change this to say map is a type which is whatever the hell it's going to be, right? I've defined map here. Let me go and make this Roboto. So this is one version of things. And here somewhere in the world, I'm going to have to say, K come. I don't have a syntax worked out here yet. The other version of that, actually, I would just use K as a type in here.
I like the second one better.
Okay, that's fine. So K and V become, and they don't have to be, okay, here you have to be careful because they are the first and the second arguments in a row. Suppose instead of saying K and V, I said Q and R. Is this expression now incorrect because I've said K and V? Or do I map K to Q and V to R?
This should be possible because it's alpha naming of the way of the parameters of the parameterizing.
I'm making sure, but if I put them up here like this, then it's clear there's an order to Q and R. And if I reshuffle my foo and my bar fields accidentally one day, I don't change all my type expressions by causing R and Q to be mapped to K and V versus the other way around.
Okay.
So I'm not claiming this. I don't have this sorted out yet. So I'm just like, here's a fail if you don't do something. So I have to do something.
And just as an aside, while I understand why Cliff is going to use K and V, in any other language that's not trying to prevent the keyboard from ever wearing out in 1,000 years, the better thing to do is to use key and value.
I would claim a whole lot of Java code uses singleton type, single car type variables.
Yep, and I would claim it's shitty.
Okay, fine.
like,
Well, but that just
I used to not think this, and someone, someone reviewing our code was like, why are you using K and V? Why wouldn't you say key and value? And I'm like, well, it looks weird. And about a week later, we're like, nope, it looks great.
In the land of type inference, where I don't have to type things all the time, I might change my opinion. In the land of Java, where I have to say K fucking V every possible place on the planet.
Well, that's a side effect of the parser design for that.
Yeah, not claiming, right. So maybe that's historical and it can go away.
Yeah, and it's historical mainly because C++ only had one variable name called T.
Oh, I.
Well, that's the thing. Like, why do you call it int? Why not just call it lowercase I or float? You could just call it int.
Fortran. Now, Fortran only had uppercase letters, but I was an int.
Yes,
IJK.
On the first assembler I wrote, variable names are limited to one character as well. So
yeah, excellent.
Like how else would you do it?
Moving past 50-year-old history. So yeah, so longer names are possible, obviously. I obviously won't put a limit on the character names. You can write what you want. The question is whether or not I need to have in the type expression, and I'm kind of leaning that you do, on the left-hand side of the map assignment as a type, you have to mention all of your dependent types so I don't have an ordering problem when you use them later. Okay, so that's one question. I kind of have an answer I like. There's a second question.
I will say on that first line, I almost want that to be an error, to be like, look, you can put the types on the map side or you can put the types on the type side. But
when you say the first line highlight, maybe you're looking at map Q or class
map Q, comma R, in square brackets equals bar R foo Q.
What are you saying? This should be an error?
The fact that you've got them in the wrong order, it should say that this Q does not agree with that R and this R does not agree with that.
So hang on. So after having written my complicated type, which is big and long, I came through and decided to do a little refactoring. And I decided, I still need this thing there, but I wanted the R to be there just to make it look prettier. Now, everywhere I've used Q and R or K and V in that order, they're wrong. Like I can't change the structure of a complicated type without causing the order of the first appearance of a subpart to change, which makes all the uses wrong. Right, so it's just like I want to change the, obviously you want to change the layout of.
And this is the same question of named versus ordered arguments in your functions, right?
No, this is the difference of named versus ordered in a struct. I have a type which is defined as a structure, has a field called foo, which is of type Q, a field called bar of type R. It's like a struct. I'm defining a struct type. I'm starting a class. It's like saying class map. I have some fields. Some of the fields are polymorphic type Q, some are polymorphic type R, some are ints, some are arrays of structs of ints of blah, blah, blah. What the fuck? Okay, fine. I want to reorder those things. Inside a class, Java class, I reorder fields. I do it all the time. Makes life pretty. Okay, I can't be having those fields which have a subtype part change what they meant when you use the type later. Is that? Ask me a question here. You're looking very.
So my understanding was that your structs were like actually specifying layout, and that if I moved a field to the bottom, I actually changed the layout in memory.
I have not.
That an array of A, Bs was different than an array of BAs.
Wow, Google quit that. Okay. The actual layout in memory is not dependent unless I come up with some new syntax saying I'm letting you have layout ordering. Because as soon as you go to any reasonable compiler, they're going to sort the heavily aligned large objects up front.
So you don't get layout unless you ask for it.
Yeah. I'm going to do layout for you unless you ask for it. Right, totally. Same as Java does right now. Java does not do layout. I mean, Java does do layout behind your back, and you actually can't ask for anything else. And there's some, real efficiencies to be gained by doing layout for lots and lots of tiny structs. You want the layout to do something clever. Most C compilers also do layout unless there's something going on where you're demanding a packing of a particular kind. And you could do that. They have a packed keyword that's exactly for, hey, I'm trying to map my struct over some hardware device. but that's not the common thing. So no. So their layout under the hood, I'm going to shuffle and you're never going to know. Okay. Having said that, when I declare this large, complicated thing that looks like a Java style, class and has a lot of fields, and I want to make it more readable. I know Cameron doesn't believe that I like readability, but I do. I'll shuffle fields around. When I shuffle fields around, I'll change the first time I use a Q and an R. But I don't want that to change how that works. So if you look at a Java type description, those types are mentioned at the start of the class description, same as they're mentioned in the Scala class type description. And because they're listed in that order, that's the order you're going to use them later when you use that type in another argument description.
So who picks whether I am constructing something by name or by order? Is it the person who's doing the construction that can either pass in named things or ordered things? Or is it the person defining the struct who says, no, this is a struct that takes named arguments?
Structs have named fields. The constructor for a struct, the default constructor for a struct, just does the fields in order as a layout thing. So if you reorder the fields, you reorder the default constructor for a struct. You can make your own constructor that does other things. And in the end, it has to call the default constructor because that's the only one there is. So if I shuffle foo and bar about, the constructor for a map thing takes foos and bars in the order that they appeared in the field layout. So that one is by order. So Cameron had this comment already that he didn't like the confusion between constructors and types. For me, when you declare a type like map here, you get in the types namespace, you get a type named map, and in the value namespace, you can constructor, which is a function call that given arguments for foo and bar produces you a map thing. Same as in Java, you would say new map. Here, I just dropped the new keyword and you've got a function called map that takes args and produces the thing.
It's always, that's something that I don't understand in some newer languages that have both like normal function calls and then have some kind of struct initialization, and these things have to use a different syntax for some reason.
I'm using the same syntax.
All right, yeah, then it's, but also, so I thought you said that one of them allows named parameters and the other one you need to provide them in order.
Named parameters are completely orthogonal. So I could also independently and a completely 90-degree axis, so yes or no, and in every possible quadrants possible, have named parameters. So the constructor that you get from map is a function. Oh, geez, I hate the thing out here. There, you get a constructor that you can call it. ASD is a map, and it takes, and now I'm calling a constructor. So I'm making a function call. My map. Yeah, let's put my map here. I better. And I do a foo thing, and a bar thing, and I got a map out. That's a standard constructor call. Now, suppose I want to have named arguments, then I might have a named argument syntax. This is unrelated to types or type arguments of any kind. This is just me making a normal function call where there's named parameters, and I'm going to do named parameter things. So here I could say something like foo colon is a named parameter. I don't have any named parameter syntax figured out.
All right, okay.
Okay, so having done a foo colon thing, I can also say there's default parameters, and I always have default parameters. And the easy default parameters, I shove a 0 in for me or a nil, so I can call map this way with no parameters, and you just got defaults. I initialize everything to nil. No.
So how do you define defaults if you already use the colon for?
So right, well, I don't have any syntax figured out for you defining a new default. I give you a default. The default is always 0.
All right.
Or nil, right? Now, do I want to have a syntax for default arguments? Maybe, maybe not. I don't know. The easy way to do default arguments is that you just do a curried function call and you just take fewer arguments and pass them along. Like here, I've defined a bunch of map calls that I'm claiming are constructors, but I could assign a new function into map. This is AA syntax, nothing to do with types. Map is a namespace assigned as a function. I can put a function in here that does whatever the hell I want. And this guy can take one argument, call it foo of type, K here, but I haven't figured out how I'm going to do that yet. And it returns me a thing of type value. And I could do something else in here, or it turns me a map. Actually, can return me a map. I don't have that map yet. I'm just going to say it can return me a map. I'm going to call the other map with the foo and my bar as a default thing. And now I've made a default argument. If I only pass one foo in, I have default bar argument supplied because I just wrote a curried function that does the right thing there. So basically, map becomes an overloaded function. It has several different versions, one that takes a foo and a bar, one that takes a foo only. And I could have the no argument version that just puts in zeros for everybody. That's how I'm going to do. That's my current theory on doing defaults.
All right. Yeah. I had languages like Rust in mind, where they've like, if you have a struct, you have like the curly braces and have name parameters. But if you have a function call, then you have the round parentheses and don't have name parameters, and it feels just like not a good solution. So this one
I have to take every
way
call.
better.
Hello. Hi, yeah, fine. All right, guys, you're on your own. I gotta take this. Sorry, I'm running a meetup for you. So.
All right, let's talk about buying houses.
Probably the topic of Cliff's.
No, I feel like we keep saying this isn't parameterized types, but it kind of feels like it's just parameterized types.
It is, at least to me. This is a type parameterization versus, I give an example in Scala up here, when you can define the types in line, or you can just define as a parameterized types, and you use them later as.
Yeah, and that makes me lean back toward round brackets. It's parentheses and just be like, look, it's a function call. It's just a function call that returns a type.
But the function call here is tricky because you have to, the function call alias is this like in the land of the terms. It's not a type. This is the distinction I would like to be made. What is a type and what is a term?
Yeah, there's a difference between a static type and a function call result. I mean, that's in trying to make the syntax look identical it's clever, but it's confusing.
I think Scala nailed this down. The type parameterization and the parameterization of the type definition is the same thing. And here you can add your constraints, or here A can play with the structural things, side of things, and etc.
Yeah, that's a good one, Cliff. What have you decided on covariance, contravariance, and invariance?
Oh, for function
type
calls?
parameters. For type parameters. Because you've got there's the Java 1.0, which is covariant. There's the Haskell, I think, is invariant. You've got a number of strict languages are invariant, and then you've got Scala, which allows you to plus and minus or whatever it is. So you can specify covariance, you can specify contravariance, and you can specify invariance on a parameter by parameter basis.
Yeah, I'm not certain I need there. I'm going to go with whatever comes out of Henley Miller, which, as far as I know, is covariance. You're going to tell me it's something else?
Yeah, I believe so. But the variance, the contra and covariance came up with the class and type hierarchies and class hierarchies. This here we have we play the structural game, and this has to be some kind of structure, and here you can play with the type. But making a contra or covariant displays with the class and inheritance chain.
So you're talking about what Java calls super and wildcard things. And then
Yeah.
Scala has the plus and minus.
They're not. Yeah, they are. As I believe they are in the same ballpark, but they are not quite the same.
Not the same
but
thing. I haven't thought that out, Cameron.
It is not a minor detail.
Right.
It is not at all a minor detail.
Well, okay. So in the normal value application, I think it falls out of the Hindley-Milner typing, but you're saying in types descriptions themselves, you could put a constraint on that says I'll not allow somebody who would otherwise match here because they aren't sub or super or something like that. It's not like, show me an example where it makes a difference sort of usefully, and we should bring that up for discussion. And then for Matt's case, your comment, that's interesting, Matt. I hadn't thought of it. You're talking about some sort of type application or type parameter names. Matt added a comment to the doc that was basically, here's type parameters, a way to do them, where it's not on the left-hand
side. Type variable. And again, I would emphasize that this is the same thing as just a variable passed to a function. So just like you have this bit lambda in system F, which takes a type and returns what some would call parameterized type, you have lowercase lambda, which is a function that takes a runtime variable and returns a value of evaluation of a function. But it is application either way. Either you have the application on the term level or you have the application on the type level. But formally, both are, either one is an application. So I don't like it. I don't write special
System F treats them the same. Either be type application or term application, it treats them the same.
Analogously, not exactly the same, because notice you have the distinction between the bit lambda. Like if you look at the type of T, you have bit lambda alpha, where alpha is the type variable, but you have lowercase lambda with x, where x is the term variable. So you have some distinction between term variables and type variables, but either one is a variable, and you apply either one of the lambdas to a variable.
Well, I don't want my typing system to be Turing complete, so I'm leery about lambdas.
System F is the easy one. That's just the polymorphic lambda calculus. That's not dependent yet.
Okay.
That's the standard baseline for generic.
We are still in the decidable, but if you have to decide the type that contains inside other type that can be parameterized, then there it gets
type inference is undecidable.
Yeah, I definitely don't want undecidable type inference.
Yeah, it's the A game is, I believe, it's at its core is a structural game, because we can play here with the type. We can somehow make the type that it has to be at least some other type here.
But you notice you already use Hindley-Milner, and Hindley-Milner is just a restrictions of system F that makes it decidable. So in a sense, you already chronologically you start with system F as the baseline, and then you put restrictions on top of it.
But restrictions are good because I get decidable.
AA is Hindley-Milner at its core. It's a top level polymorphism, if you will. Something.
I have a heavily extended Hindley-Milner, but it's not extended like everything.
In the type direction, it's not.
Maybe that's enough to justify the change in syntax and say, this is a function that takes a type and returns a type and must be decidable at typing time.
Yeah, it has to be.
Versus this is a function that is Turing complete and runs at runtime.
The typing
maybe that's enough to justify the distinction between parentheses and brackets.
But you can also use different restrictions, like in refinement types. That's still way easier than dependent type system, and you can have fully decidable algorithms for refinement types, like in refinement Haskell, liquid Haskell. That's exactly, again, the same thing. You can apply to lambdas to type variables or to term variables.
The decidability concerns if you're forced to write the type here, if you're forced to write it, or the Hindley-Milner has to infer it. That concerns the decidability of the types. if you are forced to write the type all the way, if it's a higher kind of type or something, then it remains decidable if you force it. If you have to infer it, that is where it becomes tricky.
So I want to be able to infer, which means you can't be forced to write. And that puts, I don't know what the restriction is, but it does something to the restrictions. And there's still a covariant, contravariant question that Cameron brought up that I was trying to get an answer on before we
what
alternative syntax for.
Do you plan on inheritance chain? That's when the covariant, the type has to be.
I'm currently planning on an inheritance chain sort of directly in Hindley-Milner. It's pretty straightforward to do.
Then the contrary covariance come to play.
Then yes, and then it comes to play. Yes. So
but you certainly want someone to be able to make a map from int to anything that has both EQ and hash.
This is the one.
Well, I want a map that takes things that have EQ and hash for the key. So map is going to be declared as somebody who has takes a struct that takes an EQ and a hash.
Okay, how?
So you only support hash maps.
I'm sorry?
So you only support hash maps. That's too bad because skip lists are awesome.
Yeah, but what does skip lists need?
Comparable.
The more
you have a comparable flavor.
Sorry. In Ecstasy, we call it orderable. Java calls it comparable.
Yeah, right. No, there's a comparable. There can be a comparable as well. Let's say hash maps need hash and EQ.
Right.
Something requires an ordered list can have a comparable.
Okay, what EQ and hash are this in this case? Are there interfaces or their classes or their type classes or their something?
It's structural. It's essentially an interface. It's structurally strong structural typing. If you have an EQ and a hash, that's it. There's no nominative thing about it. You're allowed in on a map, on a hash map.
But it has to have.
So let's try and write the map. If I want something where the keys in my map are integers and you have to have a hash that turns an int64,
I have
square bracket syntax. What does that look like?
Yeah, I have that floating around, and I have presented it in this group before. Here, let me drag it up.
I think I've seen the implementation of that.
Let's go find somewhere down below code block. Here, there's the horrific Google crush of the font here. Let me shrink font. It's not a very big thing, but it got wrapped. So hit a page and a half. Google later spacing. I'm gonna go one more shrink. And I want to shrink it vertically, but I don't know how to do that. It's fine. Okay. So here is, so down below, I'm looking at this code I added in there that says hashtable is it's a function of no arguments. So it's a factory. I call it hashtable with open close paren. I get a hashtable back. It returns me a struct. This is an anonymous struct. It has some fields internally, a table that I'm inferring as an array. I've given it a fixed size 7 just to be, quick and easy. There's some functions that are also local internal variables that are assigned anonymous functions. So get and put, they do sort of obvious things here. And down here, you'll see I call key.hash. And here I've called key.eq. So key has to support hash and EQ.
And here is the question. Key in EQ has to be some structure that has this function, or it has to be that type.
No,
that's why.
Some structure that has those functions, which I claim is sort of interface-like.
Okay, so if you define a structure or interface, that would be a structure with these two functions that are not defined.
Yeah, yeah, basically. If you wanted to have an interface type, you could say, I need a struct that has an EQ and a hash.
I'm hinting that
type declaration. Yeah.
I'm hinting that you have to think where you can go both ways. That the nominal way that EQ has to have these things, or it's an anonymous struct that has to have these fields.
I can be nominative as well. So I can say that hash table only takes keys and values where key is of this named type.
And the tricky part here is you have to, at definition site, you have to define what do you want the type to be, structural or nominal. If you have to do some constraints, you have to.
Okay, sorry.
If you define some constraints, you have to put the notation if you have those you require at the type or just the structural shape, if you will, the type.
Those are the same for me.
Mm-hmm.
That's structural shape is a type that demands something. So you can add more demands. So this code demands EQ and hash. You can add more demands. An additional demand is you have a named type, like I'm a capital K key thing, or named type is I'm an animal or a cat. Right. So the name is just another constraint that you can add, and it goes into the Hindley-Milner row polymorphism. Just sort of obviously you throw down the special name that you have to have, and then I'll only match if you have that name. If you don't, I'll fail to match.
Okay, but if the user decided that the key have to have an EQ interface or a name and type, if you pass it a structure that has these fields, does it qualify?
Yeah.
Yeah. Okay.
And int is a struct which qualifies because int has EQ and hash.
Yeah, that was my question. If you no matter if you define it a structural or a nominal, if you pass a structure that has this shape, it qualifies.
Yes. So I support both structural and nominal, and sort of fluidly it can cross the boundary either way, because I treat your nominative like it's structural with that name as one of the structure parts you have to have. So as far as I'm concerned, ultimately nominative is syntactic sugar over structural type.
Yeah, that was I was hinting. The nominal is just for convenience.
Yeah.
So if I want to add the type to key in this code that says you must have an EQ.
Yeah. So
how do I write that after the colon?
So okay, let me you're talking in like the search call here. Like
search, right there. If I want to add the type to that key,
is a struct which has an EQ field. I didn't say anything about what the EQ field is, but it has to have an EQ field. Okay, now I can say, oh, EQ also has to be a function that's going to return me a bool and take something. I need an arg here. A, K, Cameron wants me to say long key. So this is all still in the type declaration. So EQ is a function which takes a key, but it actually wants to take a second key, and it wants to take the self. So I'm currently heading for this syntax. You're going to take a dot, which is yourself, which is the key itself, and you're going to take some other parameter, K, and I'm going to return you a Boolean. So if I pass you a string and a dot,
if I want to be really aggressive, I could say .:k to say the K's have to be the same.
I'm sorry, say again?
Could I say .:k and imply that the dot must be in fact a K?
So if you want to restrict the table to being requiring at compile time that you're only passing in matching things, then you can do it this way. So in the land of Java hash tables, it's quite okay to pass in a frog into a table that only takes strings. And he'll say instance of string. No, you're done. Out you go. But he'll do the correct thing. Okay, but you
that's
cannot.
A runtime check in Java.
I'm sorry?
But that's a runtime check in Java.
That's correct. So to force
I disagree, Cliff. There is no runtime check. There is no check.
The user is required by the spec description, not by the typing system.
Yeah, there's no runtime type check. The only type check is a compile time, and you can cast it away. It's about as safe as C++.
I'm sorry. I write hash tables all the time where I pass the wrong stupid thing in, and I have to ask for, are you an instance of the thing that I know all my keys in the table are?
Right, but if you do a hash table of string to int, you can put a frog in that hash table.
That's what for the key. You can pass in a frog for the key.
Right.
Okay.
And you could pass in a string for the value.
Yeah, but we didn't talk about value here. We're just saying I have a hash table whose keys are supposed to be strings. I passed in a frog. Okay.
Right, but at runtime, all that information's been erased. There's no one like checking to make sure you're putting the right types in.
That's correct.
Okay, that's all.
So then in the equals implementation,
yes, in the
user
equals
is
implementation, you always check.
expected to test, but it's not required. And then he'll cast it
Class
frog to a
cast.
string, and you'll fail the runtime check at the
Yep.
array store time when you put the frog into the array of strings, or whatever your structure is that's holding string things. Yeah, you'll fail there. So that's all I'm saying that way.
It's a left associative virtual equality test, you know, so it's a.
Yeah,
But-
right. Yeah, right. And of course you swap arguments, ordering in various places, and then you get, people don't check them both ways and all that kind of shit. So you can actually lengthen this for Cameron's sake there, say something like that. And I haven't decided if the dot is a required thing, or I'll just assume it, or you can say, I don't want, it's a static call versus a non-static in Java. It just means you passed at this pointer or you didn't. Most of the things I'm doing, I'm going to pass at this pointer as a, same as Java, a hidden extra argument done, but I maybe make it explicit in the parameter list. So that's the type for key. Is that what you're, and then that, maybe that answers your question. Oh, and then you're going to want a hash.
What I'm wondering at this point is, wouldn't it be easier from a user perspective to have the hash table require 2 function arguments, one for a hash and one for the equality check? Because if right. As a user, I'd imagine I have this thing and say, okay, so what do I need to do to use it, and then have a look at the type, which and then I see this thing, for instance, for search, and I guess for get and for set and for all the other methods, there are also requirements that probably look pretty similar to the one on search, but I'd imagine that it's like way more hassle than having
so
hash table, and the hash table tells me, okay, this thing needs 2 function parameters, and that's it.
Right. Let me cover a little bit more here about what this hash table is intended to show. This is intended to show that I can implement a hash table with no types being in the code, and I'm just going to infer everything. This particular implementation of a hash table infers that key supports EQ and hash. But there's another hash table where you explicitly state your key has to be EQ and hash. And I don't have that code right here. There's another hash table where you pass in external functions that compare to k things and get an integer hash from a k thing, from a key thing. So these are different implementations of hash table with different APIs. And you could support them all. And I was just throwing out a sample. Hey, what does it look like if I wrote a dumbass hash table in AA just to see that I could write one? It didn't look insane. And what would the type inference look like? So that was the goal of this code. Then Aaron comes along and says, wait, I want to add some types, explicit types matching what the requirements actually are. So I wrote down an explicit type matching what the requirements actually are.
At no point in your practice, there aren't the parameters for the types.
I'm sorry, you broke up just when you started talking.
It feels like you got very far in adding types to this without the need for some different kind of bracket.
Yeah, that was the question I had, was did I need to do something? So it was very useful for me to do this experiment. Hey, what can I do here? You know, and here I haven't defined hash table as a type. Hash table is a function. And it takes no arguments and returns me a table, which the table itself can be typed. I could add types on the table that talk about K and V by at the end of the table saying the table's type is a thing which has Ks and Vs, and that would throw those descriptions in. So, you know, I guess I claim that I've met the goal here of
here hash table is a function that returns you a structure.
Yeah.
Returns the map, the anonymous. It can be said that it's a type constructor, maybe.
It's not. It's a factory. It returns me a thing. Now, there's another hash table I can define, which is a typed thing, which has a constructor. When you call a constructor, you get an instance of a hash table. This is a factory style.
Yeah. Okay. Yeah. It's a prototype, like we discussed it in the previous Coffee Compiler Club.
Oh gosh, Aaron, whatever you're doing for suggestions on the document, I didn't understand. So I erased one of them. It was fine. I accepted one, and it did a confusing thing. And I'm getting emails from Google Docs 20 minutes after you did it, suggesting that you added a suggestion to this doc. So
okay, I think I will avoid suggestions in the future.
Yeah, just do it.
You broke Google.
Well, you're breaking my head, so fine. But you know, just wail away on it, and it's all good.
Yeah, so Simon, that thing with the two functions you suggested is actually fairly handy. We actually implemented that in Java originally because
very slow.
It's very slow. Well, the thing is sometimes you need to be able to kind of externalize the definition of the equality and the hashing from the thing itself that may not provide.
And to provide a key and an EQ, absolutely. I end up those issues too. Yeah. In the land of Java, I make a new helper type, which just does a what do you call it? Hands it off to the other guy, not diplomacy. What's the one?
Wrapper type.
What'd you call it?
Wrapper?
Yeah, it's a wrapper. Delegation.
All right.
It does delegation. Yeah. And it's stupid. And Cameron's right. There's a totally use for a case where you want to explicit external functions.
Yeah. So in ecstasy, we don't have virtual equality and virtual hashing. Those are actually functions, not virtual. That's a long tangent there. So I'm not going to go into details. But because we still need that external hashing and equality capability, we had to actually wrap the functions with a virtual interface so that you could describe which functions you wanted for equality and hashing if you want to override it. You know, by default, it's based on the type of key, not on any interface or parameter or whatever.
Yeah, I remember a while ago, a few years, Scala people had a look at like the hash map implementation and wondered why the hash map implementation wasn't final, which is like usually a smart thing to do because it makes things easier to understand. And yeah, it turned out that basically not making hash map final allowed overriding the equals and hash code methods used. That way was like multiple ways faster than saying, okay, hash map is final, but we allow passing in the equals and hash code.
Right. That's because back then Java didn't have, I guess back then Java didn't have method handles, which would be roughly as fast now, right, Cliff?
Boy, I left when method handles came around. I had a discussion with the group that was doing them and said, this has got to be the most stupidest, worst possible way to do this thing. I'll show you a short, easy, quick hack to do this with a little bit of C2 magic that'll get you the same effect without having an entire nightmare stack. And they were like, too late, we're already doing this nightmare. And I'm like, all right, I'm out of here. I know how to do this with very little engineering effort and certainly no handles in sight. There's a stupid C2 hack on slow moving fields that are getting function called through that does the same effect.
Yeah, well,
do they get it now? Maybe they got it. I don't know.
I mean, we're still using method handles as the name. I'm sure it's been optimized significantly since.
I hope so, but
But I always,
but,
I always found it a little interesting that they were doing everything they could to avoid having functions.
I think if I look at the future, if the method handles and the lambda meta factories, and like my takeaway is that they asked, okay, what can we do to make Google's life on Android as hard as possible? And they just
I think incompetence totally, describes this. It does not require malevolence. I think
it's Oracle. It's Oracle. I think we.
Oh God! And it's easy to assign malevolence to Oracle.
No, it's not Oracle. It's still a lot of the same. There's still a lot of the same people it was when Oracle bought Sun. I mean,
I don't think Brian Getz does malevolence per se.
No, Brian Getz is the absolute.
Usually best to not attribute malevolence to what incompetence can explain.
I think method handles were done in 7 originally, so that would have been pre the Oracle takeover. So
yeah, it was, but I was already gone before then. They were coming around at the last whatever we call it, this Java summer program that they did every year, and I went to it and said, "Oh God, you guys are kidding, right? No, wait, you can just do this way. It's super easy." And they're like, "Ah, nah, we're gonna do this." I'm like, fine.
I mean, it sounds like the slow-moving fields optimization is really important, particularly for the stuff that like Max was making with Python. Python's got global mutable state all over the place that for the most part never changes. So making those things move at kind of immutable speeds and just have gates.
So for so-called slow-moving fields, how would you intercept the modification of it?
Oh, because it's slow moving, no hot code is writing to it. So the interpreter has to check the field if he's going to update some field that way, but no one cares how slow the interpreter is. And in the jitted code, you simply bail out to the interpreter if you run across some code that writes to the slow moving field. And then you declare it's not slow moving no more, and you de-opt and heroic opt and
but it has to be marked as such by the user.
No. The runtime marks it as slow moving. So it's a different question of how I detect a slow moving field. So the easy way to detect a slow moving field is I come to some code that I'm going to JIT, and somebody has done any amount of profiling about the last time that field got updated, or something about the rate of it. And this is sort of pretty easy to gather stats here about the speed of update or the last time it didn't update. And if I see this field has not been updated in a while, whatever, a millisecond or a year, I don't care, pick some number, then I'm going to JIT assuming it's fixed, and I'm going to flag it as being slow moving, and that if somebody ever changes it, that I have to de-opt.
Well, yeah, the mechanics of like how to make advantage of this fact, that's more or less clear. I think the challenge is how to detect and how to make the overhead of detection, of automatic detection, like you described. So you mean,
so if at the beginning of the function you put some like, I need to read this thing, and you put that on its own page, and then at the time that it gets bad, you unmap that page, now you're going to get errors that pull you out.
No. So the definition of a slow moving field is that dynamically at runtime, no one's writing to it. So the count of people who can write to it is limited to the JITs and the interpreter, right? And I guess you pick one up from reflection as well. Okay, fine. The interpreter needs to check a bit that says a heroic deed was done on this field. I need to go stop and do the heroic deed thing, which he does already for many other kinds of things. And then what I heard Arthur say, there were two different questions. There's one is, having declared it being slow moving, and then I've optimized it being slow moving, how do I detect? I claim that one's easy. Having declared it slow moving, however I did that, there are no updaters except maybe reflection and the interpreter, because none of the JITs are updating it, or it ain't slow moving. So the JITs just don't JIT code for updating it. They instead say, it's a slow moving field. By definition, this path is never taken, or taken very rarely, so I'll just bail out to the interpreter. So there are no JITted paths that update that field. So there's no detection at runtime on that other than in the interpreter. Okay, fine. How do I detect a field as slow moving? I actually only care if it's in some hot path already, and I'm reading it a lot, but writing it never. So now I want to have something that says, I'm in this code that's reading this guy, and I'm reading it a lot because I JITted code around it, maybe because I did C1 or first tier. is the field moving? Okay, somewhere every time somebody updates the field, I want to tag that field as being, it got updated recently. And there's a lot of ways to define recently, which you can drive the cost down to almost zero on them. One being, for instance, I cleared a bit, or I set a bit, or I set a byte on the field in the class description for the field. In the interpreter, when I'm already doing the field look, I'm doing all the field checks, I throw 0 down, that I set every other time I hit a safe point on in and around this code. There's some way to say it got changed since the dawn of time, or it didn't. And then I could say slow moving is even relegated to, it got never changed after CLNet. There are a lot of fields that never change past CLNet. A lot of fields never change from 0. After that, there's a bunch of fields that never change past CLNet.
So there is one part in this description which I think is, I guess, interesting. You said that we would need to basically instrument every write to a field so as to track this property.
Every write that the interpreter does to a field. Now, every time the interpreter writes to a field, it does a butt ton of other checks already. There is plenty of work the interpreter is already doing when it updates a field. Adding it.
Oh, wait, so you're saying if we ever compiled a store into this field, it cannot be slow moving?
Yeah, we claim it's not slow moving.
Okay.
You could also come along and say, I would love for this field to be slow moving, but I want to do a runtime check somehow that declares it, but I have jitted code that to it. So however I decide it's slow moving, say I probed it periodically with a runtime thread that said, I know this code is hot, it's read a bajillion times. I'm now looking, is the field the same? A millisecond later, it's the same. A millisecond later, it's the same. After a couple of seconds, it's still the same. What do I do? Deopt everybody who's writing to it. Wipe them all out, declare the field slow moving. They'll all reach it without.
You can also do a 2-phase opt where the first phase makes the assumption that it's not changing and tabulates stats when it does change. And then the second phase takes the assumption from the first phase and does the full opt.
That's the heroic opt. Well, yeah, okay, you're right. That's a little different. Yeah, that would be profiling in C1 followed by doing something in C2. Where the profile in C1 has included in it, it did change, or I'm changing it. So I need to go wipe anybody out who's, I need to clear the it's slow moving field and wipe out anybody who's busy trying to use the field.
Well, but it would be nice to avoid a runtime instrumentation for every store. And yeah, one of the ways to do this is just use the static fact that, okay, there is a store to this field compiled somewhere. So we expect that it happens often.
That was, there's two different questions here. One is, I want to figure out that this field is slow moving in a way that doesn't require me to do a whole lot of work about it. This is all in your profiling stage, whether it's profiling interpreter or profiling C1, whatever, you come along and you profile in the profiling portion of the world that says, what's the last rate of update or apparent rate of update on this field? Somebody else comes along and can say, I would really love this field not to change on me very often, where very often is relative to like the speed of rejitting code. So it can't change more than every few seconds or it starts to really hurt on your deopt recompile path. And then, last update, every time someone does an update, they throw down a millisecond, current time millis number. Or current time milli shifted by, get it down to a few seconds. And then when it comes time to declare, I think it's going to be slow moving, then
a more general point here is that for this kind of heroic optimizations, there is a trade-off between how much it would cost us to check the invariants and then recompile if needed versus how much gains are we getting by using this invariant.
Right. So here's the
sometimes finding the right way to check for invariants might make a difference between a viable and good optimization and not viable and good optimization.
So I claim the runtime cost of detecting that you've got a change and causing a rejit can be reduced to no cost except in the interpreter when the interpreter runs across a store. The no JIT would ever pay any cost here. Because if they're writing to it, it ain't slow moving, so they don't ever JIT the code that writes to it. They just bail out to the interpreter. You got on this path, it's going to write to this field. You must not be very often. I'm going to bail out to the interpreter. I don't need to JIT this.
Yeah, it's a big trade-off between optimizing the readers and optimizing the writers.
That's exactly correct. So the writers can just bail out to the interpreter. The readers can now get a constant. And if your reader is dispatching on the constant, that's the trick for all these dynamic, invoke dynamic and whatever. The reader is dispatching on a field content value. It's a constant. He can now fold that away. So whatever, water under the bridge. Are method handles optimized? I assume so. Did I think it was a waste of time? Yes, fine. Was I asked? No. I'm out of there.
Next topic.
Next topic.
Okay, so house inspections.
Back to house inspections.
Oh, I'm joking. I'm joking.
No, it's all good. I can do house inspections. I want to know why Google's claiming the word calling is misspelled. Why is he giving me?
Because he doesn't understand code, so he sees a sentence starts with the word TO, so you would never have a gerund after TO.
All right, fine. Yeah, I get a lot of. Yeah.
Not that I know what a gerund is.
Yeah, I heard you say gerund. I don't know what it is either. I'd say adverb. A verb to noun. All right, noun to verb, one of the two. Fine. Okay. Yeah. You wiped out my put code whenever this code got, but it fits on one page now. And I don't have color coding. How did you color code this? Who did this? Is this Aaron did this? How did you color code this?
I copy the code into VS Code and then copy it back into the doc.
Gotcha. Fine. Yeah. Okay. That's a good answer. I could do that in Emacs too. I didn't think about that.
I mean, VS Code natively thinks in HTML anyway, so it tends to copy and paste back better than, say, Emacs does.
Okay. Oh.
I don't know why VS Code is a native application that is a website, but fine.
I can cut and paste between Emacs and the website fine. And Emacs, I have to say, this code is, he'll look at it and say, it's nothing I know, so I'm not going to color code it. If you give me fundamental mode, I turn around and say, color it like your C code, and he'll do something sensible. Or Java code, he'll do something sensible.
Yes, I usually color it as Java code.
Yeah, that's fine.
Because AA is Java-ish.
Yeah, I was claiming C-ish, but you could claim Java-ish too. There's certainly a lot of keeping with the two most common languages on the planet, trying to cut down the weirdness budget. And it's already weird enough, so fine. Right. Okay, I want to scroll up. Next,
one question that I was left with is, okay, so if I take a type parameter, because I have my map that takes in R and Q.
Yes.
Why do I not need, similar with my function, some kind of function header?
You do. You got a map key arrow right there. That's your function header.
Right, but at the top, when you're making the struct.
Yes.
That is a struct that takes in two variable parameters into the struct.
Well, that's however many big long is. So it's a struct. How big are your structs? However many fields you got.
So my question is, why don't I need to say QR arrow at the top of the struct definition to say this is a struct that takes parameters in the same way that a function takes parameters?
Because I'm getting a struct back. So what I just heard you say is, and always you have to have an arrow here, 100% every time, because that arrow tells me that I have the similar, put that Google, similar syntax to a function, except that it has an @ sign instead. So I'm allocating instead of.
I mean, my instinct would be to put QR arrow at the top, so it looks like a function.
There's no, well, Q and R would be types now. So that was your prior comment that I wiped without realizing what was going to happen here. That would be this comment, which is perhaps useful as a way to put types as opposed to this.
Right. This is a struct, but it is a parameterized struct because it takes in two types that it then uses in its definition.
I don't know.
If you need to parameterize the map, how would you do it if you don't use curly brackets?
You know, there's this version. The map is a type here. I'm declaring a typed struct, as opposed to an anonymous struct, which I'm just allocating on the spot and stuffing full of fields like you do in JavaScript all the time.
Yep.
So would the consequence of that be that you can't make an anonymous type of map because the parameters that are being passed in are defined in the name rather than in the on the other side of equals?
If you do this version and later I want to use map and I don't supply Q and R, I claim I'll supply them for you as the most generically loose type.
It will in Miller, but it will infer what the Q and R means.
Q and R, that's correct. So they don't have to be passed in at the use site. So I could down below just declare map without a K and an R.
So the thing that implies that those are parameters is simply that they aren't defined anywhere in scope already.
Yeah, kind of. If you use square brackets for type parameterization, then you know that they're types.
All right, so I don't like QR on the left here because that is the first time I would have values on the left-hand side of an assignment be used on the right-hand side. I never do that anywhere else.
Right, that feels not AA-ish.
Yeah, right. So I'm with you on this version where it's like, oh, there's some type parameters here. I'm in a type declaration, so I can have type parameters. They're inside the struct. So the scope of them is in the struct.
Right. I think the scope is the struct.
So map is a type which has two parameters and returns me a type struct where Q and R, the parameters are typed there. And yeah.
Okay. If you wish to parameterize the map of the site, not the definition that uses hash, how would you do it?
Well, now I come along and say, I've got a map. So this gets into the, is a type of function, and do you round braces or do spaces? Right. And I'm still in the zone of spaces. For me, actually, calls are all adjacent, and it's ambiguous for the parens for normal calls, not type calls, not type building.
How would you parameterize this if you
I did that right below.
Yeah.
You've got in order below you the squares version right there.
Yeah, but this would distinguish of the type application at usage site and type parameterization at definition site.
Yes. So however I pass in the type parameters, they would go into the Q and R and get replaced in there.
Yeah. I would argue that the square brackets in both places are more symmetric, but it just
right. I hear you. So square brackets were, one of the more popular ones or whatever. They weren't. No one said no. People said, "Well, go use," and then they went to squares, and then I use Scala, and somebody else said, "Oh, I hate them. Angles." I'm like, angles are.
I'm obviously.
Talk about angles. Twitchy.
I'm obviously Scala biased, but I think the square are nice, just fit.
I was starting out at squares. I'm come around to liking spaces more often. I hadn't thought about this a lot, so this is all I'm like, I don't know. Let's go take a look.
Yeah, if we have to first cover the principles, the surface syntax, it's just how you would use.
Right, we're talking surface syntax. I think we understand what the types mean here. And then, things tie into like defining default arguments, which written down below, because that turns into how you make a thing of a type. You got a thing, you got a type for a thing. Now we'll make a thing of it at that type. So
Q and R are how fully saturated types. So they are no type, higher kind type or something like that, or maps or lists.
Fully saturated type.
Yeah.
What is it?
Fully saturated type means that if you use this like let's say Scala, fully saturated type means that there is no, you figure out the types here. If it's not fully saturated, you can leave it with a hole here. That means everything that's a list, I don't care what type you are using it with.
Yeah.
But if it's a fully saturated type, this means that there is no more work.
No more polymorphic variables. Those are all ground terms.
No more polymorphism. That, as Matt said, that System F can do as a type application or something.
Oh, I see. Where you would say that Q got used in a place where it was a list of underscore, and now I have a new type. Yeah, but I could do that, but that's not any deal.
Here, if you leave this, leave this for a Hindley-Milner to infer it, it's undecidable. Yeah. Oh, it's still decidable. It's still decidable, but if you go higher than this, there it becomes undecidable or something like this.
Higher than this means, but that sounds like a place I don't want to go.
A list of that's just more type variables with an unknown with underscores for Scala.
If I put new type variables in there that were other types and they have scope that goes outside of here, then then I'm not so. Then
they can. Right. Yeah, if you put more types that are parameterized, that even more types in here, then this becomes undecidable.
All right, I see that.
So Q and R here are fully saturated types, so they are concrete types, if you will.
Concrete types. Yes. Okay. So they have to be ground term basically, or have to ground really quick. I can't let it go forever. Yeah.
It doesn't have to be something that it has a type variable undefined and use it on, if you will. It can be a parameterized class. If this is, if you leave the B, if you will, this is not fully saturated type because the B is it's missing here.
Yeah.
Yeah. If you leave it, if you parameterize it, then that's a fully saturated type.
Yeah.
And this goes into the type magic that we are slowly moving with the more functional programming languages.
What I want is something I can infer, and infer actually in reasonably short time.
Mm-hmm.
And because of the extensions I've done in Miller, I don't really want to move too far from the base algorithm I'm using.
Yeah. If you stay with the fully saturated type, I believe that even with I read it with the last year, the higher kind, the rank 2 polymorphism on beyond becomes undecidable, because if you leave too many holes in the type, it becomes undecidable to infer what they mean. So if you
okay. Well, I think we're settled here then. I mean, I'll live with what you call fully saturated, ground term.
Yeah, concrete type.
Concrete type. That's fine. And you can just use another type variable at the other end, and it'll just remain as just unify them all until it hits a ground term, and then you're done. That's fine.
Yeah.
That's fine. Okay. You know. All right. I don't know if I love that or hate it, but it's not terrible, not terrible syntax.
It's look like AA-ish.
Yeah, it still feels weird to me, but so does putting the variables on the left-hand side of the assignment.
Why do you think that feels weirder than having the arguments for the function in that place?
Well, I'm sorry. Where? Arguments to functions are very...
Right. So if I didn't have an at the top there.
Yeah, you would have arguments to functions. Yeah.
Arguments to functions use that same pattern.
Yeah.
So why is arguments to structs different than arguments to functions, I guess?
Well, the first thing I had to come around to is this is an argument to a struct type. It's not an argument to a struct. Structs don't take arguments. It's a struct type.
Yes, it is only an argument to a struct type, not an argument to a struct.
Yeah. And that's what weirded me, because when I say struct, I'm like, I did a malloc in C of a thing that I cast it to whatever thing I wanted, and I have some fields in there I'm going to scribble into. I did a malloc.
Just as a clarification, those are parameters to a struct type.
Yes.
Not arguments. Sorry. Sorry for being pedantic.
Well,
the point is you need to know how many bytes to malloc, and it is dependent upon the two things that got passed in, how many bytes you need to malloc. Yeah.
So some point in the once type analysis is done, Q and R get reduced to ground terms. Now I know what Q is as a ground term type. And now I know how big foo is.
Right. So you know what Q is in that specific type, because you can have any number of these map types.
Yes. So this type, you're correct. This type does not know the size of foo, because this type knows that foo is a Q, and there are many places where foo gets mapped. At each allocation site, making a new struct, I will have a concrete type for Q.
Which is to say you have an infinite number of map types.
Yeah.
Each of which could have, if you chose to do it that way, could have its own code implementation.
Yes.
how would look further restriction Q to have these methods would be, can we to further restrict the Q that has to have an EQ method inside?
I just said you just said this. Oops, not here. Here.
Mm-hmm.
Q is anything that extends an
That-
EQ, which is a concrete thing.
That looks right to me.
Yeah, that's it. That's the constraint way. The Q is further constraint to contains these things.
Yeah, I don't do any constraint things. I do standard unification Henry Miller, but
this really looks like self-types in Scala now. It's like, as usual, if a language has something, it's like it's Scala somewhere.
Yeah.
Yeah,
Right, but is that a compliment? Is my question.
Sorry?
that, is it a bad thing?
No. I believe Scala pioneered a lot of things that are pretty advanced in most of the ways. And right now, most of the language are still lacking in some area. Scala was at the frontier, so just advancing a lot of the things. So Scala doesn't pay me to say this. So I just like the ideas and the concepts. I just don't like that it's slow. So, okay.
Well, one of my goals is keep performance, so I'm going for zero overhead abstractions wherever possible.
Yeah. So if we further constrain the Q, we can use it here, like a foo.eq.
Yeah.
Yeah. And then
somewhere in the code below. So this is a type description.
Yeah.
Okay. So well, we can get into more things that are AA that are not commonly known here. This is me thinking through stuff. Anytime you put a variable down here that is signed as a final assignment and it's a function call, then I can, with a zero overhead abstraction, move it off to basically a map.class object. The function call can do, I have a key colon Q because we're using Q for key here, arrow dot in the middle of your code. You can say, key.eq of whatever and carry on. So this is part of the type, but I'm defining code. The code carries or picks up types from, the type descriptions or Q or whatever it's going to be, but it defines essentially a constant. The code is just a constant. So as long as I'm putting constants with final assignments in a type, that's fine. The type has some final assigned constant values. And then I'll, as an efficiency hack, a zero overhead hack, I'll move all the final assigned, constants off to the side somewhere. And instances of maps won't have a get field directly, but I'll know that since you have a map guy, I can go over here to go get the one version of the final constant for that map guy, the get call.
And that's how you get ints that have functions but aren't bigger than 4 bytes.
Functions, yeah, that still live in 4 bytes, yeah. They're typed in the type system as being a struct called int colon and whatever. And they have an EQ and a hash and whatever things they have. And then I know that because they have a known type that I can go look up that int type at typing time and find it in my list of known types, and the zero overhead is the description of those functions is over there. So I'll scroll down and get away from maps for a second, somewhere near the bottom, code blocks. Internally to the type system, X is bad name here. I is a lowercase I. Don't uppercase me, thank you. Internally, it looks like a struct. It has a magical val field, has your value, and it has EQ equals, and it has hash equals, and so on and so forth. There's some two-string version in here. Fine. So the zero overhead is all the final values get moved off. The val field is the only thing left, and there's nothing I need for the wrapper, so it's just 4 bytes, a container 3. It's strongly typed as a int colon struct, and the lookup mechanism says, I don't find EQ in just the val equals 3, but I'll look at the int guy, and he'll go tell me to go over there. So you can more or less claim there's a version of this which looks something like, let's just do this a different way here. kind of, sort of, I'm looking like you're an int 3 : you inherit from int as an inherited value.
Yeah, that's a dependent type, basically.
And then I wouldn't have said dependent type, because as far as I
But
know,
it's roughly the same concept, though.
is it?
That each so dependent type is basically the intersection of values and types, right? So like the best way to approach it is to think of enums, right? So if you have an enum color, you've got R, G, and B, right? R is a color, G is a color, and B is a color, right? So in a sense, R is a subclass of, in quotes, depending on the language, R is a subclass of color, just like 3 is a subclass of int. So that's all a dependent type is that you could, in theory, say you can pass any color to this method, or you could say, in theory, you can only pass a red to this method. Because red is both a value and a type.
I would say that dependent types are this, as you describe it, but they can be, a value can be completely, that a type can be completely dependent on a value. If you say 3, then the type becomes Boolean. If you say 4, then the type becomes string. And that's a perfectly valid dependent type.
I don't follow that.
And you can make a type perfectly dependent on a value. That a dependent type means. You can make a, it can take a range of ints, if you will, a range from 1 to 10, but from 1, if you see 1, the resultant types does, if you let's say if you have a function that takes a one integer and one type that depends on the integer, that is a perfectly valid dependent type definition. Then the first type, the second type depends on the first type. If it's 1, then the second type takes a Boolean. If it's 2, the second
like
type
a switch expression, for example.
Yeah, if you will, but at the type level, that's the key thing.
Yeah, I'm not going there.
And that's what the dependent types are made special for. They are strongly, the type is strongly dependent on the value it takes.
Yeah, no, I'm not going there.
Well, it's a matter of taste, and that mechanism I described opens the door for more complicated things that are made with dependent types.
Now, having said all that, in my current worldview, the int : value is 3 is in fact also a type.
The value 3 is a constant 3.
And a type of
type 3
that are exactly 3.
Yeah.
Right. That's why I gave the enum example, because it's very simple to think that red being part of the set of enums of colors must be, say, the Java case. So I say enum color open curly red comma green comma blue, right? Close curly. So I've defined 4 types. I've defined color, red, green, blue, and I know in Java that it creates an abstract class called color and 3 final implementations called red, green, and blue. That's subclass color, right?
Yeah.
So I have 4 classes, but I also have 3 values. Right.
Yeah.
So red is both a value and a class.
Yeah. In this case, it can be said that because the enum has a constructor in set that it selects the type by index. If it's 0, then it's red. If it's 1, then it's blue, and etc.
And similar to an enum, I can never pass an int as an argument, ever. I can pass a 3, but I can't pass an int.
Yeah, but here
I can pass a 7, but I can't pass an int. Int is an abstract concept, so it's kind of like color. I never pass color as a parameter to something that takes color. I have to pass some value of color, right? So red is a value of color, just like 3 is a value of int. But red is also a type, just like Cliff was saying in AA, he can have 3 as a type.
Yeah.
It can say 3 is a type, and it can make a function that it takes only 3, then doesn't take an integer.
You can do that. So you can imagine here in Cameron support, the red eye remover is a function which takes a color which is known to be red only, and a pick which is some kind of image and does something, right? just for documentation's sake, it's going to take the red eye, the red of the red eye, which is just one color because we only have one red.
Yeah.
But it's useful documentation.
That's what the color would only take the red.
Would only take the red, yeah.
The key to red eye removal is to always fly west.
Never take your pictures while staring into the okay, yeah. Yes, I'm going to be staring at the west and the setting sun. It's going to be very interesting. A lot of red eyes where I'm going to end up. What else?
Alan was going to say something, maybe. I don't.
So red only has one possible value, but might still be useful for disambiguating which version of a function to call.
Yeah. Stupidly, I have that in various places. I have some function which has too many parallel arguments in Java code, mind you, where I say dummy is of type float. Why? Because no one ever uses Java floats. And I just needed you to not fucking overlap with some other function named dummy, because usually it's a constructor issue and I'm fixed in your function names. And so I had to pass a dummy, get a different constructor. I hate it. Fine. Whatever. Java, only Java issues. But yeah, I passed argument disambiguated, stupid arguments that are dead.
You could imagine if there's one really common thing that gets passed in, that you could be like, here is the version of this function that takes 3 and does the 3-dimensional version. And here's the version that takes 2 and does the 2-dimensional version. And then here's the version that does an n-dimensional, much more slow, complicated thing.
That's essentially a type specialization, a function that is tailored to a specific implementation.
Will AA yell at you and say, hey, you gave me this function for 2, 3, and int. You're ambiguous, or will it say, no, 2 and 3 are clearly more specific than int. You are not ambiguous.
Yeah, so my current theory is that as long as your types arguments tile the type space, no overlaps, but they can subtile, then I'll claim more specific. So I said color eye cleanup, but if it was red eye, if it was color eye cleanup here, I would claim I ought to be able to disambiguate these two cases. One takes red specifically, one takes a general color, which includes red, but I'll call the first when I know that you have a color red. Now, can I always tell that you have a red versus a color? Do I require you to disambiguate at runtime? Which of these are you going to get? I'm not going to do a runtime test. So that means if I can tell that you're a red specifically, you get the one, otherwise you get a color. Now, did you intend to call the red one and you didn't, and you forgot to make sure that your color was typed as red? You got the generic one. Do I like that ambiguity? No. So I haven't figured out what the right answer is. I know I can disambiguate on tiles reasonably, tiled arguments, which one you get. What I don't know how to do is how well it feels if you write some complicated code where you call color eye cleanup. So you're busy doing oh, color eye cleanup, and I took a foo color and a pick, and I kept going, and I accidentally missed that I needed to declare foo color as type red. If you did this, you got the red one. You did this, and foo color turned out to be not inferable as red, but only inferable as color. You got the second guy. That means that it's not obvious from the text and the code which one you're going to get. And I don't like that ambiguity. So
because one can be determined at runtime, one can be determined at compile time.
Yeah. And the color one might be something utterly unrelated on your eyeballs when handed red than the red eye cleanup one. You can imagine one does some generic good thing where he decides your eyeballs shouldn't glow like the sun and tries to do brightness matching and shit. Whereas the other guy is specifically looking for tints of red and trying to remove them and then bring out the other colors such that it looks like you have natural eyes and not, the other thing you get out of that is red got just subtracted off and your eyes still look weird.
This pushes the optimization to find out as much as it can about a type so it can...
Well, inference happens and always gives you the most general type. So I'll tell you what you got for foo color, but it's not obvious from the text that you're writing, the code text, that you got a red or you didn't, at least not in this little snippet. In some larger context, you can tell clearly, oh, foo color is of type red because I fucking declared it red or whatever. Maybe.
Yeah, but here most general type is a kind of misnomer, because if at compile time the compiler can figure out the type is only red, then this is the most general type. If it's used a red and blue, then it has to go to color. If it's used
right, exactly. That's what I'm saying. This can really quickly lead you down the path where you call the wrong thing.
Yeah.
So I use this disambiguation trick for for like operator plus and shit like that, where I have the int function, the int type is got an operator plus, which is a function which takes self and takes an int and does a primitive. I can't type today, but there's another version which does floats. Yeah, whatever. And this is, I is an int here and D is a float or whatever we're going to do. So I allow this syntax and I'll disambiguate on your second argument being int or float, and you'll get one of the two functions. So it's int plus int and int plus float. Okay, that's where I'm at currently with method overloading, and I can tell those apart at type inference time that I'm tiling the argument space. Now, does this cause ambiguity over which plus you get when you start mixing large complicated expressions? No more than widening does in every C and Java program on the planet when you mix ints and floats everywhere. Yeah, I'm not going down SAT solvers, Cameron. No. Oh, you love that, hate that syntax, Cameron.
Sorry, different thread, the Simon's link to the self-type thing.
Oh God, okay.
And this isn't going to get confused if I try to call something with an uint 53 that is an int64 and a uint 64 and a float.
Well, right now yeah, I could put in int 53 as a, obviously bit restricted version of an int. The problem, of course, your results from all your int plus ints that overflow to go to 54 and you fail being 53 right away. But you have an overflow add that does something, returns you 53s. The first level of dispatch is always on the left-hand argument. So all operator calls, when I call I plus j, I look at the type of I, decide it's an int. I look at the plus as an infix position. I build underscore plus underscore, and I do a lookup on int on the left-hand side type. I get a choice of two functions which depend on the next argument in. Now I do type disambiguation. So the first rule is all operators are just function calls, and they're always done on the left-hand argument. They're always dispatched against the left-hand argument, every time. Oh, and Theodore says,
sounds sufficiently deterministic.
Oh, and what is your comment? Does that have to do with the typing?
I'm not convinced exactly that this user with the self type is exactly going on in AA, because the type can be structural, and here this pointer only concerns the hierarchy. It should be extendable in this way.
Now you're making me look at self types.
And the main point is the second trait, that this column user, the second trait tweeter, this qualifies as a self-type.
I'll have to stare it. I'm not going
to. The trait tweeter, the second this column user is a here is the definition of a self-type that requires the tweeter should be extended by user. That requires and the trait is too abstract. It's too abstract. It doesn't know where it will be implemented. But in the code, it said that this has to the whoever extend the tweeter has to extend the user as well. And
so here, would you read trait as interface in Java? Is that kind of a...
yeah, the trait is equalizer to interface in most cases, I believe.
So if I just say I'm extending you with tweeter, it's like an implements an interface.
Yeah.
And there's a tweet function that has a default argument. It's basically similar to a mixin with the default function argument.
Well, it seems like in this case, they could have just said trait tweeter extends trait user, right? Because they're both abstract. So it's basically saying I'm picking up, to be a tweeter, I have to also be a user.
Yeah, this is the so-called cake pattern in Scala, because this user can be anything. So you in Twitter you import functionality that has to be you know that it has to be extended. It has to be implemented at some point. So the trait tweeter is too abstract, and you import functionality by saying that this whoever extends the tweeter has to extend the user as well, because you don't know.
On that one, I like Java just says, oh, I'm an interface user, I extend interface. I'm interface tweeter, I extend interface user.
Well, that's why I think this example is probably a crap example, because there must be a better reason for the syntax than I can almost do it a Java interface.
The main point is you import functionality in abstract type. You import another interface in another interface, and you say that this functionality should be available, and it allows you to use in the body of Twitter, but it knows the whole trait. It knows it has to be extend the user as well.
Right, that's what extends gives you.
Yeah.
And I know Martin's brilliant, so he must have had something more complicated in mind than this.
Fun fact: there is special code in the compiler to deal with this syntax and to recognize whether it's a self-type or a lambda, and it's like things you didn't expect to clash, but.
In an earlier version of Scala, this actually was a keyword. It was requires in the Scala.
Wasn't the other reason for traits though? And I'm going back like so many years I can't remember, but if I remember correctly, the reason he had to do traits was because he wanted to subclass code that he didn't own, like Java string. He needed to add something to string, so traits let him add something to string.
That would be extension methods. That would be extension methods.
That's different. That's different from this. Okay.
Yeah. Traits are basically simply interfaces with implementations.
Yeah.
There are some slight differences between Scala's traits and Java's default methods that led to the unfortunate reality that Scala C still has to do additional work and can't use Java default methods for Scala traits, but the intention was basically the same.
I see. So traits came before Java default methods, and then they had to.
And then basically, as usual, people didn't talk to each other and realized that things didn't work out way too late, and then it's Java. Java is Java. You can't change anything again anymore after it's shipped. So Scala is basically emitting stupid additional code for the rest of Java's lifetime.
Yeah.
See, that's the challenge for Scala, is because Java is still evolving fairly rapidly for a 25-year-old language.
Yeah.
You know, when C++ came out, it didn't have the problem of C evolving, because basically they didn't make any improvements to C for like 20 years after C++ came out.
Yeah.
Yeah, but also the C and the C++ committees talk to each other, and they sometimes even have some kind of overlap, and that's
they do now, but there really was no C committee until they threw something hastily together for 99.
Since C is developed again, they also talk to each other, and that's just not happening in the JVM space.
I like your comment there. 30% chance Martin just needed it somewhere. Just added it. That'll be me. Oh, fuck, this is stupid. I'm just add this right now. Bam. 2 years later. Oh, that was a really bad, poorly thought out plan, huh?
But there is something to be said in language design, how easy it is to add shit and how absolutely difficult it is to remove it later.
Yes. Yes.
So,
hey, stability is a really important value. Once you've got users, you don't want to break their code. Like,
yeah.
Unless you're building C#, in which case, fuck them.
I think that's.
Well, if you got a budget, then you don't care.
I think the notion of this kind of notion of stability is very short-sighted, because in the end, what you're saying with this, you can't change anything because you have users, is that your existing users are more important than your new. Exactly. Yeah. Basically, if you're saying, okay, my language is dying, that's of course the correct approach to take, to never change anything.
But on the other hand, the code I wrote in '96 is still running in production and still compiling today in Java. And the code I wrote in '99 and 2000 and 2001 and 2002 on C#, every year it broke when they released a new version. Like,
for the latter, someone is making some money maintaining it. For the former, it isn't.
Yeah, I've never had Java code that I needed to rewrite for a new version of Java, whereas I have already had to rewrite a lot of Python code and even Go code.
Go, yes. I acknowledge, but Python code you had to rewrite?
Our Python 3 migration was expensive.
Oh, Python 3, you're not done with Python? Python 3's been out for like fucking ever. I thought everyone was off Python 2.7.
I believe our migration ended in 2020.
So that was a long tail migration. I mean, you're going to still find people on Python 2.
Oh, Jesus. Okay.
That just proves that you have to have types. Just in a large code base, you cannot go without types.
Oh, God. All right. Fine.
It's more complicated than that, Theodore. Well, I'm not a Python expert, so but
me neither.
But the thing is, Python builds the type system as it executes. Aaron, maybe you can add two
sentences. Just runtime types. Don't build no type system anywhere.
Right, but order is important, and
you evaluate shit, and that gives them, I guess, types.
And the meaning of what the type is determined at runtime. It's not determined statically at compile time.
Right, but it's so, like in the small, it seems simple, but as the system grows, the ordering of things, it's like it just gets unfathomably complex.
Yeah, you can prototype in Python things very quickly because you don't have to worry about types.
Yeah, going back to what Aaron said about stability, I think it's stability is important, but also what I miss in many languages is an effort on changeability, saying, okay, we want to be stable, but what can we do as a language to make it easier to evolve or to evolve the standard library or whatever, so that if a change is needed, we have like an approach that can be used or not, so that the language is not forced to say, okay, we can never ever change anything because we simply don't have a story on how to change things. And I feel
how did
many
Rust
languages
go after this? I have a vague memory of someone saying in Rust you could have multiple different block parts of your code compiled to different APIs, but all compiling the same API, so they call each other.
The Rust language approach is that they never ever change anything, and so basically on the API level they never ever change anything. On the ABI level they don't guarantee anything. So basically every minor version of Rust needs to be recompiled from source, or like code. If you switch to a new Rust compiler version, then you need to recompile all your source code. So you basically can't have dynamic libraries in that sense. And
yeah, I haven't come to that point yet. Decided.
Yeah, it's also not a great thing in some cases. And, what I might be a bit partial, but what I really like is one piece in Scala where you not only have like the deprecated annotation, but you also have like deprecated inheritance. So you can say, okay, I have this class is not final, but I want this class to be final somewhere in the future. So I put a deprecated inheritance annotation on it, and then the compiler knows to only warn if somebody subclasses this class. And I think that's a good approach. And in general, like your deprecation annotations need to have a version string on it. That's like basically no deprecation without a version. Either to say we deprecated this in version X, or saying this is deprecation, that this is deprecated and we remove it in version X.
Interesting. Yeah, I haven't thought about.
Yeah, it's like I spent quite some time fiddling on that. So if you have like multiple libraries in Scala with various deprecations and with various versions in which things are deprecated, there is at least some effort made to basically print you the list in some sensible order, saying, okay, foollib has deprecated things, and you are using these three, and from the standard library you have like these things, and they are deprecated in the following version. And yeah, but it's certainly not optimal. I think Rust compiler warnings and error messages are still far ahead of most languages.
So what of that do you think is good advice for a new language that's trying to be capable of moving forward?
I'd say one the modifiers as annotations, or annotations as modifiers, is one thing that I think is really interesting. So the ability to say, okay, I have this keyword like thing, but if I like find some bug in the private keyword, I can simply define a new one and import that instead, and basically gradually fix broken behavior in the language by simply importing the right keywords that are annotations underneath. I think that's a nice thing. In general, lots of diagnostics and annotations to drive them, like the deprecated inheritance, deprecated override stuff, and also on the surface level of the API or ABI, having at least some kind of abstraction for field access and method calls. So if you have like if you have a person and that person has a name and an age, callers shouldn't have to encode in their code whether like accessing person.age or person.name is a field or method or anything else. I think that at least would add some robustness there.
Yeah.
I mean, currently in Java, we basically say everything has a getter and a setter. And yeah, that's
why I hate getters and setters.
Yeah, I think it's sad because we kind of get this robustness, but we lose all the information the IDE could give us if we wouldn't have to worry about the difference. So if you could have like could have a class, and it could have like some name attribute which might be a method, might be a field. It doesn't matter syntactically, it doesn't matter from an API perspective, then the IDE could use color to indicate, okay, person.name is like a method call, or person.name is implemented as a field, and that would be a lightweight approach to have both the robustness for change and conveying more information to the user in an IDE, which is currently simply not the case for like Java's getter setter approach. Like getter setter, the IDE doesn't care whether like the getter setter is a trivial field access or whether actual work happens in there. It's like it's not
the user had to write .get and .set.
Well, that's what sucks.
Yes, but not knowing the performance overhead also sucks if you wanted a field because you knew you had a performance issue that was tied to it. So concurrency on field access, it's crucial to know whether it's a field that I have in my hand or some function. Shared memory concurrent access.
Yeah, but in that case, the IDE can tell you that exactly, which it can't if you have getters and setters around everything.
And I'll also disagree, Cliff, because I understand that you occasionally work on things where that matters, but you are in the 1% where that matters.
But this is the bug. The bug is that people get it wrong in so many different ways, and then it becomes bad, so they give up and they quit trying to do it. And it's not that bad. And you're like, no, it's Cliff. And bullshit. I've trained all kind of engineers at H2O to go do this shit. It's totally a learnable thing. So I don't know. I'm frustrated for sure.
My point is, if the overhead were Java's overhead of a getter, that is not anyone's performance bug other than yours. Like no one else has ever seen that as a performance.
The bug is not knowing what .get does.
I'm just telling you that is not anyone in the world's bug. Like no one has ever been bit by that except you.
Unless the thing that you don't know about .get is that it does a network RPC.
And the great thing about Java is years ago they hired this guy who built a compiler who eliminated the cost of the get anyway. So
it's not that I know that the cost of the inline get or not inline get is the issue. The question is, what is the function get doing? Is it making a network call which can fail or block, or is it doing a field load? Oh, I have to go look and see. Multiply that by every fucking field access on the planet, and I can't get shit done because I don't know whether I'm talking about a field or a function doing a goddamn database call. And it's crucial to do certain things one way on the database call and not others.
I totally get it, but most applications aren't falling apart because they're calling the get. Most applications are falling apart because they're talking to the database.
Yeah, and what I'm trying to say is, if I have a getter that I can't tell at a glance is just a wrapper over a field, I have to now go ask the question, what the hell are you, Mr. .get?
But in this case, IDE can tell you if
right. So if instead there's no .get in there, but now it's either a field or it's a whatever you want to call it, a thing that you're going to wrap a getter and a setter around, but the IDE colors it, then I can tell at a glance, I'm talking about a field. I'm not talking about a field. And if I have a concurrency issue, I want to be able to come along and say, this fails if I'm calling out to a getter and a setter. It's just wrong. It's a type error if you call a getter and a setter here. You give me a field, I need a field. You're not going to give me a field, you're going to give me a function that does something, oh, error. That would solve the class of bugs relating to, what the hell did you do here? It was incorrect.
All right.
Right. So color coding, yeah. Maybe the type.
I just think that most developers spend 99% of their performance optimization efforts on things that make almost zero difference, while still hammering the fuck out of a shared database. Like
yes.
Like so, it just if you've ever, if Kirk were on, he'd be.
But as soon as I talk to C programmers, they're still very, very much excited about knowing that they have a field or they have a function to a getter setter.
Yeah, that's because they're coding for an I-960. It actually matters. Like there are no C programmers that aren't in the embedded space anymore.
No, every game writer on the planet.
C++ or C#.
C++ guys too. They fall in the same camp.
No, definitely not. Definitely not.
All right. fine.
C++ is different.
We run with different crowds. It's all good. All right, I'm going to claim victory anyhow, or I'm going to claim I'm hungry because we talked about homes and equity and whatever. God, I can't even say the words now. Geez, title companies and escrows and everything else for 30 minutes. It's a good talk, but you know, fine. And my house is a higgledy-piggledy mess and almost an empty box. It's actually pretty close now. You can see the pile behind me, but that's one of the few piles in the house. There's not so much there as there were a week ago.
We will
Thank you
start
all.
Alan's question next time because you didn't.
We have another question missing.
We will start at the next time.
Well, okay. So next Friday, 50-50, I'm going to have internet and a desk and an office and shit, or I'm going to be up to my eyeballs in moving boxes. So if you see me on Twitter, you know, we're good. And if you don't, somebody else can make the call and call the program out. But
That's what I said last week. We just make Tito our host.
Oh, I would try. I would.
You want to do that?
I would try. I would make everything possible to make it happen. Why not?
Mailing list, if you want that, I can do that.
Okay. I would do my best to be Cliff. Just don't talk about me C2 compiler stuff yet.
All right. So Theodore is in theory hosting next week. He will send out links, I'm sure.
Okay.
I'll send you, right if we're done here, I'll send you the mailing list. And I usually just take the cut and paste form and change the, the BCC, the people on the mailing list, change the Google Docs, change the date. Sometimes I forget half the time and done.
Okay.
You're a brave man, Theodore.
Yes.
We'll see how it goes. So they say. Okay,
right.
guys.
Till we meet again.
Okay, till next time. See you guys. Bye.